Okay, so we're starting fractions, obviously, today by looking at our vocabulary. We're going to define these first three kind of in our own words. So how would you define what a numerator is? What would you say?
The top number in a fraction.
Bingo. Okay, so we're going to call the numerator, it is the top number in a fraction. Now, the other thing I want you to know about a numerator, let's say we have a pizza that has 5 slices and you eat 3. So how would we represent that as a fraction?
3/5.
3/5. So the 3, the numerator part, shows the part of the fraction. So the numerator shows or represents the part. Because remember, a fraction shows a part of something, not a whole. So the numerator, the top number, shows the part. Alright, so the opposite of that is our denominator, and what would we call that?
The bottom.
Absolutely. It's the bottom number of a fraction. So if the numerator is the part, what would the bottom number be?
The whole.
The whole. Exactly. If you ate all 5 pieces, you would say, oh my gosh, I ate the whole pizza. So the denominator shows the whole. Okay? So you have the part and the whole. And that is supposed to be an L. Alright, so right here, when we talk about simplifying, okay, I just lost my train of thought. Oh, simplifying. What is simplifying?
It's where you take like a fraction that's like 10/20ths,
Mhm.
and instead of having like 10/20ths, you make it smaller and like 1/2.
Okay, make it smaller. I like that. There's some other words that you'll hear used like interchangeably. One of those is reducing. Okay? So simplifying is reducing a fraction to its lowest terms. Yeah, exactly. So you'll often hear reducing, lowest terms, simplifying. All 3 of those phrases mean the exact same thing. Okay? So simplifying is just reducing a fraction to its lowest terms. And we do that by using the GCF. Anybody remember what that stands for? I'll give you a hint. Greatest. See, I knew you knew it. Greatest common factor. Okay? The GCF, or the greatest common factor. That just means the number, the largest number, that both your numerator and denominator share as a factor, which just means it can evenly divide both of them. Alright, later this week we're going to start adding and subtracting. Actually, tomorrow we'll start adding and subtracting fractions, and I hear wonderful things that you guys rocked fractions last year, so I'm expecting you to remember everything you learned, okay?
I did rock fractions.
Good. Okay, but today we're going to talk about how to convert decimals to fractions and fractions to decimals. Okay? Decimals and fractions show the exact same thing. Okay? I like to call them mathematical, is that right? Mathematical synonyms. Okay? Because decimals and fractions show the same exact thing. We can write them to represent the same thing, but we can also convert them back and forth. Converting, of course, just means changing. When we're changing a decimal to a fraction, I want you to remember this. You are going to write what you say. That's your rule right there. You're going to write what you say. This tells you exactly, okay, the number behind the decimal is your numerator, the place value is your denominator, then you simplify. But guys, it's even easier than that. You just write what you say. Somebody read number 1 as a decimal for me. Bryson. No, right here. Read this. How would we say that as a decimal? What? One more place. Hundreds. Okay? So listen to what you're saying. When I read this as 98 hundredths, well, how do I write 98 hundredths as a fraction? 98 hundredths. You're just writing what you're saying. So when you listen to it, you have to understand that, those could be both. Now, from this point, of course, we need to simplify. What's a good starting place when they both end in even numbers, Hannah? Well, if 1's my greatest common factor, then it can't be simplified. That's okay. Think about it. If they're even, they can always be divided by 2. Okay? So what is 98 divided by 2? 49. Okay? And what is 100 divided by 2? 50. Now, remember our little trick? When your numerator and denominator are one number apart, that's the lowest terms. It can't go any farther. So that's all you're doing. It's a lot of mental stuff, right? Not a whole lot of working it out, and I get that, which is fine. Okay, look at number 2. Somebody read this as a decimal. John William.
15 and 715 thousandths.
Perfect. So look, I'm going to write exactly what he just said. 15 and 715 thousandths. Why is my 15 over here? Because it's a whole number. Exactly. So with our whole number, that's not part of our decimal. So it kind of stays over here by itself. I don't have to do a whole lot to him. Now, 715 over 1,000. That's a big number, isn't it? Okay? Is there any number that we know that could go into both?
5.
5 can. And I will go ahead and tell you, I've worked this out so many times today, that it will be 143 over, what's 1,000 divided by 5? 200. Excellent. Somebody in the back there said it. Oh, good. Okay. That's all you do. You write what you say, and then you simplify it. That's easy enough, right? Okay. Especially when you get to things like 3/10. You just write 3 over 10. That's it. All right, let's talk about how we go the other direction, converting fractions to decimals. Okay? Our rule here is we always divide. To me, the coolest thing I finally figured out, here's my division symbol. What does my division symbol look like? A fraction. Because guess what? Fractions are division. Writing a fraction is another way to show division. And to me, it's almost like they made the division sign to represent a fraction. I'd like to say they did. Okay. One thing you need to remember when setting up the division is your denominator is at the door. Okay? Denominator is at the door. Always numerator divided by denominator. In years past, when you set up this problem, somebody would have told you, you can't do that, right?
No, you can't.
Oh, yes we can.
Because you put a 0 and you put an 80 on.
But I'm not just putting a 0. What have I got to put first?
I don't know.
Decimal. Okay, decimal. I like to start with 2 zeros. I don't know that I'm going to need both of them, but I like to start with 2 zeros. Okay, so now I'm not looking at 18 going into 8, but 18 going into 80. How many times? Let's try. 10's going to give us too many.
4. 7.
I agree. Let's try 4.
Yeah.
Okay, 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. How many do I have left over? 8. Bring my 0 down. What's happening again? It is a repeating decimal. And we figured that out within 2 places. So 4/18 as a repeating decimal would be 44 hundredths.
8/18.
Yes. Now, let me ask you another question. Okay? What if I were to simplify this fraction first? Would that change my answer? No, it's not. Okay, let's simplify this one. What number can go into both? 2, so that becomes 4/9. Okay? flip to the back of your page for a second. I'm not sure if I showed you guys that yet, this or not. I want you to write down a couple of fractions. I did show you this?
Show us this.
Okay.
I don't remember.
Jot it on the back of your page just so you have it, because I think it will come in handy. Because there will be some of these things that you don't have to work out, that you can just know off the top of your head. What is 1/9 as a decimal?
1/9.
As a decimal, not a fraction.
1/19. No.
What's 2/9?
2/2.
3/9.
3/3.
4/9.
4, 5, 5, 6, 6, 7, 7, 8.
All right, don't get ahead.
Oh,
Children. It's just Andy. What about 6, 6, 6?
Okay, so earlier when we had that fraction that was 8/18 and then it became 4/9, we could have immediately known, or 2/9, I think it became 2/9 or 4/9. We could have immediately known that 4/9 is 44/100 repeating. This is just a good rule to go ahead and know. All right, everybody see the pattern? Good? Okay. Any fraction over 9, and we're talking 1 through 8, is going to be that number repeating. It'll be one whole. Okay, so let's go back and look at our next one. We got 5 and 16/20ths. What do I do with my whole number? Somebody said it.
nothing.
Nothing. We just put it over to the side. Okay? And then I have 16 divided by 20, decimal and 0. How many times will 20 go into 160? 8 times. 8 times 20 is 160, and I have nothing left over. So that becomes 5 and 8/10. Now, here's something else I'll show you. If I have a fraction like this, how do I write 3/10 as a fraction and then turn it into a decimal? Somebody said it. 0.3. What about 300ths? 0.03. What about 3,000ths?
0.003.
Okay, so what I want you to see is that if I can get a denominator that is 10, 100, or 1,000, changing it to a decimal, you don't even have to divide. Could I have done that with this?
Yeah, you could have done it by 2.
Divide both by 2, so that will become 8/10.
No, you have to do it by 4.
But look, if I just want this as a 10, 4 is my greatest common factor. You're absolutely right about that. But if I just wanted a denominator of 10, I could divide both by 2. That gives me 8/10, which is 8/10. So there are some shortcuts where you don't have to actually divide and solve it, okay? But then you have a lovely denominator of 45. There's no way to make 45 turn into a 10, a 100, or a 1,000. So we do have to divide on this one. What do we do with our whole number? Put it to the side. So then we've got 4 divided by 45. What do I put after my 4?
So that's decimal and the 0.
Decimal and zeros. I always start with 2 usually. This one I knew was going to end in 1, so I didn't. Okay, can 45 go into 4?
No.
Can 45 go into 40?
No.
No. What have I got to put right here?
A 0.
Because I've got, now that I have my decimal, I have to have a placeholder. But 45 can go into 400.
8 times.
8 times, very good. 8 times 5 is 40. 8 times 4 is 32. Plus 4 is 36. If I have 400 minus 36, 360.
40.
40 left over. If I add another 0, guess where we are?
Repeating decimal.
Repeating decimal. So 7.088, and the 8s are repeating. We did get a lot of repeating decimals. Your fractions that are multiples of 3, 3, 6, and 9 as denominators, you'll have repeating decimals. Think about 1/3, 2/3. Those are. Yeah, you can. You're going to have one left over.
No, we do Dillingham.
Okay, we're going to do a couple together. Hang on just a second. We're going to do a couple together before we move on. Will you give everybody one of those? Thank you. When you get your sheet, I want you to go ahead and make a couple of notes. Up at the top on the first section where we're changing decimals to fractions, what was our hint on that? Decimals to fractions. What do we do? You write what you say. Okay, so up here we're going to say write what you say. Okay? And the second half, fractions to decimals, we are going to divide. Divide. So in the first half, you're going to write what you say. Second half, you're going to divide. Absolutely. Yeah. Yeah. I want you to use your notes now. We're going to keep practicing this for a little while, too. Okay. Somebody read number 1 for me as a decimal.
0 and 3,500.
Perfect. So how do I write 3,500ths as a fraction?
3,500.
You got it. 35 over 100. Can I simplify that?
Yes.
Yes. What number will go into both? 5. Okay. What is 35 divided by 5?
7.
And 100 divided by 5? Try to get 20. You're good. I knew what you meant. I knew what you meant. So, at that point, we are done. This is not something that's going to require a whole lot of computation working it out, okay? But you do have to think through it. All right? Read number 2 for me. How do I read it as a decimal?
12 and 9.
12 and 9 what? Tenths. So look at this. 12, 9, tenths. Can I do anything? That's it.
No, you can't.
Because they're one number apart. Whenever they're one number apart, they're simplified.
Be simplified.
Do what? Nope, that one will stay as it is. Okay, somebody read number 3. Read that one for me, Hannah.
75 and 225,000.
You got it. So my whole number, 225 over 1,000. Yes.
25.
Yes. 25 is my greatest common factor between the two. And guys, whenever you see numbers like this, you can always jump. Think money. Okay? I know you guys know money. But if, like Alex just said, 25 is our greatest common factor. So how many times will 25 go into 225?
11.
Think about this. How many times will 25 go into 100? Okay, 4. Okay? So if I've got 225, I've got 100, then another 100, I'm up to 8, then add one more to it, 9.
Wait, what?
Okay? If 25 will go into 100 4 times,
40.
and there are 10 100s and 1,000,
Go into a 4.
yes, 4 times 10 would give us 40. Okay? So let's skip past 4, 5, and 6. Did you have a question? Okay. Let's skip past 4, 5, and 6. Let's look at 7 real quick. Okay. 2 ways we can do this. 2 ways we can do this. Is there a way to change that denominator to a 10? Yes.
Multiply both by 2.
Multiply both by 2. So if I do that, this becomes 6 and what?
2.2.
2 tenths, which we can write that as a decimal as 6.2. If I had divided 1 by 5, guess what I still get? 2 tenths. Same? So you're going to get the same answer. As long as you can make this denominator a 10, 100, or 1,000, that's going to be your easiest bet. You see what I did?
I just.
Okay. Based on what we said a while ago, what are we going to expect on this decimal?
Repeating decimal.
Why is it going to be repeating?
Because it's a multiple of 3.
Okay, my denominator is a multiple of 3. So 3, 6s, and 9s, those are going to give me repeating decimals. Okay? So what do we do with our whole number?
Put it to the side.
Put it to the side. Okay, so now I have 4 divided by 6, but it's really 40 right here divided by 6, and that'll go how many times? 6 times. That gives me 36. 4 left over, bring down my 0. We've already figured out this is going to be repeating. So 94 and 66 hundredths repeating.
I got a question.
Yes.
With I know 9, it's the numerator that is repeating.
Mhm.
But with 6s, what is repeating?
Not.
There's not. I'm trying to think if there is a pattern to it.
There's not a certain way. You still have to divide it.
Right, you still need to divide, but it's always going to be repeating. Yeah. 9s are the ones that have the pattern. Yeah.
Is this
Do what now? Oh, yeah, sorry. That should be a 4. Yeah, and then bring another 0 down. Sorry. Yep. Good eyes. Good eyes. Okay. 8/15. I don't have any way to change that denominator to a 10 or a 100 or a 1,000. So I'm going to do 8 divided by 15. Okay. How many times will 15 go into 80?
6.
6 will give us 90.
4.
5. Okay, so 5 times 5 is 25. Go back one. 5 times 1 is 5 plus 2 is 7. I have 5 left. Bring my 0 down. How many times will 15 go into 50? 3 times. That gives me 45. And look what's going to happen. Repeating decimal. The 3's are the only part that's repeating though. So on this one I don't have a whole number, so it's just 533 thousandths repeating. Okay, are there any questions so far?